In this video, we'll be going over binary tree zigzag level order traversal. So given the roots of a binary tree, return the zigzag level order traversal of its node values from left to right, then right to left for the next level and alternate between. So in our first example, we have 3, 9, 20, 15, and 7. In our first level, we're going from left to right. So we have 3 here, and it only have a single node value, so we just output 3. In our second level, we're going from right to left because we want to switch our direction. So we get 20 and 9, so we output 20 and 9. And then in our next level, we change our direction again from left to right. Then we get 15 and 7. So we output 15 and 7. Let's go over the thought process. Let's first go over a regular level order traversal. In the level order traversal, we created a queue to keep track of our nodes. Then in each of the iteration, the size of the queue determines the number of nodes at the current level. And also the direction that we always go in is left to right. But in this case, we actually need to go from right to left. But instead of going from right to left, we can instead just add the node values. But instead we can still go from left to right, but we can just add the node values to the front of our list instead of to the end of our list. So for example, if we are currently moving left to right, if we are adding elements or adding node values to the end of the list, we are essentially still moving left to right. Then if we are adding node values to the front of the list, we are essentially moving from right to left instead. Let's go over the pseudocode. So let's validate the input parameter. If roots is null, then we can return an empty list because there's no values. And then we're going to create a list results to keep track of all node values. Then we're going to create a queue to implement our level order traversal. And then we also need, before that, we also need a Boolean variable. Is right, just to indicate that we're going rightward or leftward. So currently we're going rightward, so it's initially true. And I'm going to add our roots to queue first. Then I'm going to say while queue is not empty, create a linked list, because we may need to add node values to the front of the list, so we do not want to shift elements. To keep track of the node values at the current level, then we're going to retrieve the size of the queue to determine the number of nodes at the current level. Then we'll iterate through the indices from 0 to size -1. Then we can pull a node from queue. Then if it's right, it's true, that means we want to add the node value to the end of our list. So we add node.val to values. Else we want to add node.val to the front of values. This means we are changing our direction. Then we're going to, if node.left is not null, we're going to add node.left to queue. If node.right is not null, we're going to add node.right to queue, which basically allow us to find the nodes for the next level. Now we want to add values to results, and then we also want to change our direction for the next level. So I'm going to set is right to, it basically changes the direction true to false and false to true. Then we can return results. Now let's go over the time and space complexity. Time complexity is of n, where n is the number of nodes. We visit each node once. Now, its space complexity is also is 2 times n, so it's O of n. This is because of our resulting list and our queue. Result list plus queue. Let's go over the code. So we will validate the input parameter first. If it's null, we can just return an empty list. Now we want to create a list to keep track of all node values. Then we want to create a queue to implement level order traversal. We're going to create a Boolean variable to indicate our current direction. Initially true because we're moving rightward, and then we add our root node to queue. And then while queue is not empty, we still have nodes to process. We're going to create a linked list to keep track of the values at the current level. And then we're going to retrieve the size of the queue. Then we're going to iterate through the nodes at the current level. We're going to pull a node from the queue. Then if its right is true, this means we want to add the node value to the end of our current list. So values.add node.val. Else we want to add it to our front of our list. So values.add 0 node.val. Now if node.left is not equal to null, this means we want to add it to our queue. And then we'll do this same thing for node.right. After we traverse the current level, we want to add the values list to results, and also allow us to switch our direction for the next level. Then we can return our resulting list. Let me know if you have any questions in the comment section below.